be on my bottoms. I finna beat up a bitch up in Gaza. Max Hall pull up the bitch and it ride him. Since I got me spinning like round a bitch, round a bitch. I'm about the oxen, I can't even doubt a bitch. High phones in, I keep hitting on the side of bitch. That's the last time that I ever gon' start a bitch. I ain't never trippin' about it, bitch. Fucking the cash, I be running out on this bitch. The key is unnecessary to go start this shit. Know when shit come out, so shawty go start this shit. I'm trying, run my boy, I won't be part of shit. Niggas is blocking, you know I be hard as shit. Fast on the highway, I'm dark shit. Got this shawty, she know she be hard shit. I get hard shit, it's just my conscience. I'm trying to talk, she wearing my eyes.
So I'm studying this textbook called just Algebra by a person named Gelfand. I don't know his first name. And Mr. Gelfand is a fucking lunatic. This textbook is 150 some pages long, whereas most algebra textbooks might be 800 to 1,000, and he does not waste a single word in this thing. Every single problem is meant to teach you something new. And what I'm realizing is that the depth and complexity of algebra is far, far more than that of calculus, or at least what I have learned of calculus. See, if you ask me, the only reason you learn algebra before you learn calculus is it's not because calculus is harder. It's because you just need to know algebra to do calculus. And if you ask me again, I would say that the reason most people fail in calculus is because they're just not good enough at algebra, and the algebra is getting more complex. Actually, never mind, I think I'm wrong about that, because when I studied calculus, we were all using calculators that could do algebra. But just to give you some perspective, I was studying this algebra textbook all day yesterday. My entire purpose of that day was to study that algebra textbook. Can you guess how many pages I got through? Like 8. It was 8 of them, which is honestly great because that's like 1/15 of the textbook. I keep going for 15 more days. I'll probably get through most of it. It just makes me question everything that I thought I knew about math. I thought I was so good at math. I was better than all of my classmates. I didn't even have to try. And then I open up this shit, and it's like a big slap in the face, big smack. Like, you're an asshole. That's pretty much what this book is telling me. You're an asshole. You don't know shit. One of the problems is, let me just paint a picture. Try to see if you can wrap your fucking head around this. You have two fractions, a over b and c over d. And these fractions are what are called neighbors. And all that being a neighbor means, the best way to explain it is probably to give you an example. 1/2, 1 over 2, and 2 over 3 are neighboring fractions. Now, the rule isn't necessarily that the numbers go up by 1, like 2 over 3 and 3 over 4 and then 4 over 5, although that actually might be the case. But the quality that made them neighboring fractions, as described by the book, was not that. It was the fact that when you subtract one neighboring fraction from the other, let's say you subtract the smaller one from the larger one, that results in a new fraction, obviously, that has a numerator of no more than 1 and no less than 1. Forgive me for making it more complicated. It's just the number 1 in the numerator. And then the denominator has to be the product of the two denominators in the first two fractions, a over b and c over d. So the denominator needs to be b times d. So for example, 1 over 2 and 2 over 3 are neighboring fractions. If you subtract 1 over 2 from 2 over 3, so forgive me, I kind of set it up so that 1 over 2 would be A over B, but we're going to flip that. So let's say A over B is 2/3, 2 over 3, and then C over D is 1/2, 1 over 2. And let's subtract 1 over 2 from 2 over 3. And when you do that, you get 1/6. That is 2 times 3. So 1/2, you take the denominator of that, 2. 2 over 3, you take the denominator of that, you get 3. You multiply 2 and 3. Together, you get 6. That's the common denominator. That's how you get a common denominator, is just by multiplying the 2 denominators together, which is actually, I didn't know that, believe it or not. I just kind of always winged it. And also, it probably goes without saying that 1/6 has 1 in the numerator. So the problem essentially was saying that assuming A over B and C over D are neighboring fractions, assuming that, prove that neither A over B nor C over D can be simplified any further. Meaning, let's say you have the fraction 3 over 9. That is a fraction that can be simplified further. Why? Because you can divide 3 by 3, and you can divide 9 by 3, and you can get 1/3. 3 over 9 is the same thing as 1 over 3. Think about it, like 3 goes into 9. So I had to prove that as long as 2 fractions are neighboring fractions, no matter what neighboring fractions they are, not a single one can be simplified. Shit was confusing as fuck to me. Like, when I tell you that I was sitting there for at least 70, 75 minutes trying to figure that shit out, I have never spent that long on a problem ever in my life. Especially a problem where I had pretty much gotten nowhere. And I guess it's the fact that it's a proof, because from what I understand, from what I've heard at least, it's much harder to prove something mathematically than to just solve a mathematical equation. Like, whenever I hear graduate or PhD level mathematicians talking about some research that they're doing, I feel like it's always they're talking about a proof that they're working on. And so that makes me think that maybe a proof is way harder. Though I could be wrong, because that's not incredibly irrational. It's not an incredibly rational way for me to think. But regardless, I'm really proud of what I did after that problem, though. After that problem, that was part A of problem 42. I remember it vividly, like it's a traumatic event in my life. After that whole number fraction neighbor problem, we moved to part B of the same problem, which was assuming the same thing about A over B and C over D. Prove that A plus B over C plus D is in between the two numbers, and prove that A plus B over C plus D is a neighbor to both of the already existing neighbors, A over B and C over D. This confused the fuck out of me too. Because, like, they're already neighbors. How can you have neighbors within neighbors? That doesn't make sense. And then I ran some of the numbers for this shit. And then I got really confused because the math was not working out. The proof was not making sense. Nothing was simplifying. It was this big mess. And so I was, like, really feeling discouraged. And I was about to, I felt like quitting, I'll tell you that. And so I was like, wait a second, a plus b over c plus d. If I had two neighboring fractions, let's say the same ones, 1/2 and 2/3, and 1/2, that's 1 over 2, that's a over b. So 1 plus 2 is 3. So that's the numerator. And then I have c over d, c plus d, that's 2 plus 3. Actually, let's do it with 1/2 and 1/3, which are also neighbors. If you have 1 over 2, that's a over b, that's 3. And then if you have 1 over 3, that is 4. 1 plus 3, that's 4. If you have a plus b over c plus d, that's just the numbers in the first fraction added together over the numbers in the second fraction added together. So that results in 3/4. 3/4 is not between 1/2 and 1/3. It's greater than 1/2, and 1/2 is greater than 1/3. It's not in between. So I looked into it, and apparently, there is a fucking printing error, a typographical error in the goddamn English translation of the textbook, because the textbook was originally written in German or some shit. So it was an error in the textbook. And that made me feel really fucking cool, because it reminded me of that one time when Kobe was shooting around before a game and he was missing all his shots, and he was like, yo, something's wrong with this hoop. He didn't question himself. He questioned the fucking hoop. And yes, I'm comparing myself to Kobe Bryant right now. Fuck off. He was like, yo, something's wrong with this hoop. I think it's the wrong height, because I think he was like missing all of his shots like long or something. Like he was long on all of his shots. And I checked the hoop, and it was like 3/4 of an inch off. And then they fixed it. And then he was like, and then he started making all his shots again. Like, that's just fucking crazy. So that is pretty much everything that I accomplished yesterday while doing this shit. And I don't even care, because I only got through like 8 pages, but I feel so accomplished. And then I forgot to mention that after I switched the problem, because the problem, what it was supposed to be was, it wasn't supposed to be a plus b over c plus d. It was supposed to be a plus c over b plus d. So it was supposed to be the numerators plus the numerators added together over the denominators added together. So once I plugged this in, I tried the proof again, and everything like canceled out beautifully. It was fucking amazing. And the proof turned out to be true. So I'm learning how to do proofs, I feel like. Not formal proofs with like, I'm pretty sure formal proofs have to follow very specific vocabulary and format and shit. No, I'm not talking about that. I'm just talking about logical proof that a math problem is correct.